Thank you very much for inviting me for this conference. Sorry for my voice. As you can hear, I actually have some problems with that. Now, talking English, I can pretend that I have this really low temper, so I will try to talk slowly and deeply. So, 5 things to consider when you plan to discover and automate your predictive models on top of Apache Hadoop. Sounds like a very technical speech, doesn't that? Well, it actually will not be very technical. It will be more like going further with what Piers already said in the first presentation of today. I want to share with you 5 most important things that I have learned in our project, realized here in Poland for Polish real customers. But let me start with a story first. So it was a sunny day, one of the first day of May. As you know, we have the bank holidays on the 1st and the 3rd of May here in Poland, so we usually take the 2nd and 4th and others free, so we are home with the families. So there is the regional logistics manager, let's call him John. He's working with the retail chain, with logistics. So he's enjoying his free time with the family. He is on the countryside, and out of a sudden, there is a phone call, a business phone call. Of course, the wife is furious. She asks, "Who is calling you on vacations?" And he takes a look on the phone, and it's the senior vice president, the very strict one, you know, the Lord Voldemort of the company, right? So he picks up the phone, and there's a question. "John, what's going on? We are running out of water. We will have empty shelves in like 3 hours if the trend will not change. What are you doing now? What are you going to do with that?" And then John says, "It's quite impossible. I checked all of the orders 2 times before my holidays." So the boss asks, "But what are you doing now?" And he says, "Talking with you, sir." "No, besides that?" "Yeah, sitting on my veranda and, yeah, drinking water, right?" And the boss says, "Do you think the other people drink water or not? It's like 30 degrees outside. It was 20 last week, now it's 30. People drink water when it's hot like hell. Why didn't you actually predict that? Why aren't your decisions data-driven? You should have known that, right? The weather forecast is a public information." So you can imagine that John was pretty scared about his situation. But that's a funny story, right? We usually don't think about it. As humans, we are quite interesting species. We are doing different things when we are forced to join the new requirements of the environment, for example. So something that I have learned, and it will be one of the examples, one of the stories that I will show you today, is that we can try to describe our life with the model, with the numbers. However, it's not very obvious most often. So when you think about the mineral water in the retail chain, for example, it's a very specific product. It takes a lot of space, so it's huge. They don't have huge space in the store to place this water there. They need to deliver that just on time. And what we do as customers, when there is 0 degrees of Celsius and the temperature goes up till 5, we buy the same amount of water, doesn't matter. When the temperature goes up till 10 degrees, doesn't matter, the same amount of water. When it goes up till 15 and 20, doesn't really matter. We buy the same amount of water. But when the temperature goes above 25 degrees and it's hitting 30, we are buying 800% more, right? So it's a huge for those retail chains, right? Well, yeah, so John should be data-driven. We say our businesses should be data-driven. Our customers try to build a data-driven business. But what does it really matter to be data-driven? You know, it's like a buzzword. You can find it anywhere. Anything is based on data nowadays. But what we observe with our customers is that it's actually kind of a journey that you take. So you usually start with data denial. You have some data, but you distrust it, you don't use it, you try to avoid it. Then you try to go a bit further, try to start your care about data, but still, your data indifferent, you don't care. It's there, you know it's there already. You may trust or not, but you don't feel the need for that. Then you begin to be data informed, which means that you are starting using your data. However, it's only for those situations that you feel that it will back you up, not everywhere. And then it's data-driven, when you are using your data to shape and inform all of your decisions. So it's a journey. When we think about data-driven things, we usually think about data science, right? As Piers mentioned in the first talk today, this is actually the small but very crucial part of the whole process. You will probably see this slide in different variations many times today, the life cycle of data science. But what I'm going to show you today is that data science and its cycle is not the one and only. It's actually the part of the whole process, right? At Trisoft, or Trisoft in Polish, we are partners with Hortonworks. You know them, right? Hortonworks, the Hadoop vendor, one of those two main vendors. So I'm using those slides from Hortonworks today to back up my deck with few information. Because as the title said, as you may expect, we are using Hadoop platform to automate our data science models to provide various insight to our customers. We are using HDF and HDP, Hortonworks Data Flow, Hortonworks Data Platform. We are putting them together and we are running our models on top of that. I will be referring to the slides later when I'll be talking the next stories, but you know, when I think about our data scientists inside our company, and you know, I'm not responsible for them. I'm responsible for the guys who are taking the models from the data scientists and then they run it on production. So the architects that design the whole infrastructure, the DevOps that take the model and run it at scale in the cloud or on-premise. And we usually observe that data scientists in the modern data architecture, they are usually hitting a wall. They have many questions regarding how they should operate with the data using the newest tools, the newest libraries, the newest technology stacks, and it's not easy to be up to date all the time. So one of the main problems that we observe is how to get the model and run it at scale on production. Usually, when I think about data science process at our company, the data scientists, they completely forget about that there is some kind of production environment at the end, right? So it's like a research project that they do, and it's really fun to do because you can test different statistical methods, you can test on different data sets, you can create different hypotheses and verify it, but at the end, they don't care about production. They just say, take this model and do whatever you want. I'm done. Which is not very good for the project at the end, because the customer usually asks, so is the model ready? They say, yes it is. So the customer asks, so when can I see the result? And we say, whoa, it's ready on the, in the lab, on your laptop, in the sandbox, wherever, but it's not in the production. So this whole process of operationalizing the model is really crucial. So the 5 things that I wanted to share with you, they are arguably the lessons learned that I believe are very important in attacking all of those modern data science issues that our data scientists have. First of them, I usually think about it as the holy grail of architecting. Do not over-optimize. It refers to the model, it refers to the process, it refers to the environment, it refers to the whole project at the end. I'm not sure how it's here in Gdańsk, but in Gliwice, where is the Silesian University of Technology that I graduated, they usually say, the professors and teachers, they usually say that you should have all of those different aspects in mind, and when you are creating the architecture of your system, you need to think about those aspects. And that's, of course, true. However, if you spend too much time on creating like a perfect architecture, you are doing nothing for the project, but you are living just in your engineering dream, right? You are creating a perfect environment that will never happen in an imperfect world. So when I think about optimization, there's actually one thing I believe we should really optimize. It's time to market. You should take your process, take your project, take your model, and get it to production, get it to the market, test it in real life. Let me give you an example. We are working with the retail chains, so the grocery stores you probably usually do your shoppings with. I cannot say which one, but this is one of the biggest here in Poland. So what we do for them is we are forecasting sales. So every day for next week, we know how much products will be sold in each store individually. So we know, for example, that here in Gdańsk, in the store which is like 1 kilometer from here, it will be more or less 120 kilos of chicken sold tomorrow. So we have those models, we have those information, which is then very useful for the customer. Because you can imagine that it's really crucial. Before our project, in the retail chain, there was a store manager, hundreds of them, because they have hundreds of stores. These people were wasting 2 hours of their time every day to go over the store with the notebook and pencil and just write down how many chicken I need, how much chocolate I need, how much tomatoes I need every day, based only on the so-called expert knowledge, right? Which is really error-prone. Right now, the whole process is automatic. It goes from getting data about the payments, about the receipts that you do on the cash registers. It goes automatically to the Hadoop platform. Hadoop is calculating the aggregations on this data. The aggregations are used to feed the model. The model is retrained every period, depending on the model. But then every night we calculate over 10 million forecasts for each product in each store. And this project was not easy. You can imagine how many aspects are there when you think about going from prototyping to production. And the key to success of this project, and this is success really, because we are working in production for 2 years, and we are really benefiting from that, customer is really benefiting from that. The key aspect of this project was not to over-optimize the whole story. So we started with something really, really small, but actually providing value. When you think about retail, the retailers, they are running on very low margin. They are fighting each other. You can see the adverts in TV, right? The Polish retailers, they are the biggest advertisers. They spend millions of zloty every month just for advertisement. And there is a lot of questions. Should I spend 5 million more or 5 million less? But maybe in different channel, maybe not in the internet, maybe in radio or in TV. In our project, we had to focus on very, very different things, let's say. For example, when you think about meat, nobody likes to buy the last piece of meat in the store, right? So you come to the store and there is, you're late, okay? Let's say it's 8 p.m. So they are closing the store in 5 minutes. You are the last customer. Will you buy the last piece which is on the shelf? Probably not. But that's the perfect forecast, right? You know, we have forecasted that there will be exactly this amount of meat. No, it doesn't work that way. We are humans, we are thinking different. So we need to take into our model different information, not only the sales history. Time to market. That's the key to not over-optimizing things. Take your models to production as soon as you can. The second story, or the second project I would like to refer, is from a completely different sector. It's from insurance. This lady here on the photo, she's not taking selfie, she is buying insurance. Believe it or not, but the insurance company tried to extend the feature set that they use for feeding the models with very new data types, with very new data information that they can derive from different things. So of course, the fitness bands, the Apple Watch, everything which is collecting data about your health, this is crucial for them. But there are actually projects where they analyze your selfie to verify if you're obese or if you smoke cigarettes. We did such project 1 year ago for the Polish insurance company. So it's not science fiction. Of course, they cannot use it directly in the model, which is giving you the score at the end, because this is a regulated market. They must give you the price based on the criteria that can be verified. If you will use machine learning, you don't actually know what happens inside, right? But if you are using machine learning just to detect some features and then get the weights to those features, it's perfectly okay. So, use the right tools. That is the motto from this project for me. Starting this project with the customer, we got the information that there should be like zettabytes of data that we will analyze. So we spent probably like a month or two with the architecture team to design the environment. It was based on the Hadoop cluster. It was really huge. In our design, the sizing was really huge. At the end, the customer said, I don't have so much budget for the infrastructure. We need to make it happen on something smaller and then we'll go further. I said, yeah, that's the right attitude, just not over-optimize, yeah? So we started, we built the smaller cluster, not so huge as we expected from the beginning. And then it looks like there is maybe 1% of the data that we expected. What does it mean for data scientists, for example? They were forced to use the tools which were intended to work on a big data set. Those tools were installed on a small cluster. So having the tools and having the data, they said, this will not work. My SQL statement takes like 5 minutes, not 5 seconds. We can't work with that. And we can say, yeah, okay, of course there is always a problem with that when the customer doesn't know what he wants and so on. But when you are using not the right tools, all of those questions arise. How do I collaborate? How do I share my work with others? It's very painful for data scientists, right? Just imagine that you have your laptop and you have your R studio and you love it. And now a guy like me comes and says, no, you must use Apache Spark with Apache Zeppelin on top of that. And there will be huge security and governance over that as well. on your laptop because the customer doesn't have budget for infrastructure. Yeah, so it's not the right attitude. Probably I don't have to say that this project was a failure at the end. The third thing that I've learned is to govern your data from day one. You start a project and you usually say, okay, let's put all data in the data lake in some bucket. Let's don't care about the format. Hadoop is schema and read, who cares? Let's put everything in there and then we'll start analyzing data. We have such project with one of our customers from financial services sector. And you know, where there is a merger between different banks, then they put all of the data about the customers, about transactions into one database, into one, let's say, ledger. Usually is the good way to do that. However, when there is a third, fourth, fifth, and sixth merger, you have such huge data duplication that it's really hard to verify how many customers do we have. Let me give you an example. Let's imagine that you are a BI specialist, so you design reports, and it's your first day in a new job. You are working for this bank, and there is a vice president who comes to you and says, nice to see you here, good that you will be reporting directly to one of my directors, but I need very urgently this report because I have a meeting with regulator, with KNF. And you say, okay, what report do you want me to prepare? And he says, I would like to know how many active customers do we have? Okay, sounds like a cliche, right? Number of customers, easy. So you go to your direct boss and you ask, there was this vice president and he asked for the report. Where can I find the data about our active customers? Because I need to prepare the report. And he says, whoa, so that's a tough question, because when you will ask about the business definition, what really is an active customer? If you will ask guys from marketing, they will say that there is a person, that the active customer is a person who is answering the phone call every day if you call them with some offers. If you will ask risk assessment, they will say that, yeah, the active customer is the one that is having a loan and is paying that every day or every month. When you will go to the call center, they will say that the active customer is the lead that they get about him every day. So it's not actually your customer yet. He might be in the future, but it's not in the moment. So in one organization, you have plenty of different definitions of the same thing. And then, without proper governance on top of your data, without data tagging, without actual security, but not only security, it's also the business glossary, it's also the metadata, it's also the master data. Without this, governed all together, you are running into data swamp, not data lake. Yeah? You are building a huge data set that nobody knows how to go through, how to find some valuable information into. So, luckily there is this infrastructure from Hortonworks. There are those frameworks like Apache Atlas, like Apache Ranger, where you can build your actual data measures, yeah? your data governance definitions, but people need to use it first. People can do amazing things with data, and we already know that. Let me give you another example from the bank, not the same bank, but from the banking sector. So there was a bank that said, okay, we have a huge Hadoop data lake, we can put there anything. Let's just put there every single data record that we have from wherever, from all of the systems. So they started recording the call center calls. So every single call was recorded and put as the MP3 file on the Hadoop cluster. There was no business case yet. They were just putting data because they wanted to use it in future, not knowing how and why. After 2 years, they have noticed that this huge Hadoop cluster is running out of resources. The HDFS was full, and 85% of that was the call recordings. So they said, we are not using this data yet, we don't know how to use it in the future, let's just convert that into, let's just convert voice to text, and we will have just a text. They did the project, it was a huge project, took like several months to convert all of those recordings. And after that time, after maybe next year, there was a startup nearby, and they came to the bank and asked, you know what we have? We have a software, we have the machine learning model, which is able to analyze the sentiment out of the voice recordings. We can now improve the quality of your customer service significantly, because we will tell you that this customer is really angry, this one is happy. This is the information which is crucial for providing those scripts for the call center people, right? But they didn't have the voice recordings anymore. They had just a text, and there was no sentiment to be found. Why is it interesting topic when we talk about using the tools for data tagging, for example? Because if you are not tagging your data, if you are not creating the metadata on top of your data, you are not describing your data in a meaningful way, then you really don't know if this data is useful, if this data will be a huge data in the future or a small data set. You cannot really manage that data. If you have data tagging, you can build security on that. You can build all of those, GDPR rules on that. You can also build rules for the Hadoop platform to move your data to the cheaper storage, and there is no problem. You can just take your data and place it there. Don't lag behind. So we have this project for. It's a project that we realized with 12 different polyclinics from the whole country, and we collect data about the process of treatment of children that suffer from one specific type of leukemia. And we take this data and we correlate it with the genomics. So when there is the new diagnosis, the new children that comes to the doctor, and he says there's leukemia, we can check in our Hadoop cluster what was the best type of treatment applied to the children with the closest possible genomics. I know that this kind of project is opening a lot of questions about ethics. We have huge concern about data privacy and security in this project. But when you think about what we actually can do with our data, is marvelous. Yeah? If data can save lives, why shouldn't we do that? The interesting observation from this project for me was that, in every hospital in Poland, there is the statistics department for 50 years or more. They must keep and store our data there as long as you are alive or dead. But they never use it in the right way. They are using these data sheets in paper, not in the digital format usually. The doctors who are building the therapy, they are not able to use it. So when we think about data science, when we think about applying machine learning to data, we usually think about something like rocket science. But sometimes, when you really lag behind with your technology, when you lag behind with the processes around processing data, it's really simple things that you can improve, and it will bring you to the next level very fast. For those doctors who are using our data, the biggest value is not that this is the Hadoop platform or that we have the data scientists working on that. The biggest value is actually that we have put all the data in one place, that they can find those correlations. This is something completely different that they did before. But this this project also opened many questions from our data scientists, but also from the researchers from the universities, from medical universities. And this is a huge problem. How to be up to date with the technology? How do I learn the latest library technique? How can I be that good in everything? You know, when I am a data scientist, I'm trying to be best in statistical models, in mathematics, in computer science, in programming, maybe in business knowledge also. Well, it's clearly impossible to be that good in everything, right? That's why we are coming to the last thing that I have learned. And this sounds really provocatively, right? Don't build your data science team. Don't do that. Why? Because you need to build the whole big data team or the whole analytics team. And it's not only data scientists that work there. So you need business analysts, you need data scientists, you need developers, you need data engineers, you need DevOps, you need architects, you need someone who will be governing the whole project, right? So referring to, again, to Pier's presentation, that's not the one-man show. When you think about data science, it's a team sport. Just remember that. When you will be building just a data science team, you will be doing research projects, not something that the customer in the real life will be able to benefit from. A nice example that I have from one of our projects is that there was a project like several months ago, and we thought it's really a small proof of concept. And our data scientists, they said, okay, we can handle it ourselves. We don't need data engineers here. We'll just take data from the customer and do the modeling. What they have generated at the end as the result was completely useless. And there was this, you know, like usual, project war. Who is the father of the failure? And you know what was the main problem? This. They have created Excel files as the result. That was just a proof of concept, so there was no fancy BI system as the output. It was just an Excel sheet. The problem was that they didn't know, as data scientists, because you know they know ARIMA models, they know gradient boosting, they know different sophisticated statistical methods. But they didn't know what every single data engineer knows, that in one Excel cell, you cannot place more than 3.2 thousands of signs. So the Excel files they created, nobody was able to open them. It was like, I don't know, several months of work, okay? So you need to put there the right people. You need to put there data engineers, domain experts, other guys who will take care of that. And one thing which connects that very much, the real learning about how your model operates happens in production, not in the lab. So the main takeaways that I would like you to remember from my presentation, those things that I have learned in the last years of the projects, they are those 5s. Arguably, there are many more. But these 5, I think they were the most valuable for me. Thank you very much.